Hello students, today we're going to look at section 8.4, which is special products. Now we're still multiplying binomials by binomials in these special products, but we're going to give you a few little shortcuts that may help you in the process if you ever see these types of problems. Now if you want to work them out the long way, you can work them out the long way, but these are shortcuts that you might want to use. And the first one is called the square of a sum. So let's take, for instance, I'm going to write it algebraically first, and then I'm going to do some examples. Let's say that I have a plus b squared. Now if I wanted to, I could write this out as the quantity of a plus b times the quantity of a plus b. And then I could use FOIL. But I want to show you a shortcut on how to solve these problems. The shortcut is this. You first square the first term. So that's going to be a squared. And then you're going to do 2 times a times b. So that's going to be 2 times the quantity of whatever the first term is times whatever the second term is. So 2 times a times b. And then the last term is going to be b squared, or the last term squared. Now let's look at a real example using numbers and stuff. So let's try this with 3x plus 4 squared. Now once again, I could write it out as 3x plus 4 times 3x plus 4, and I could use FOIL, but I'm going to show you the shortcut way. So the first thing I have to do is take this first term 3x and square it. So what is 3x times 3x? And that is 9x squared. And the second thing I want to do is do 2 times 3x times 4, because I'm doing 2 times the first term times the second term. 2 times 3x is 6x, and 6x times 4 is 24x, so plus 24x. And now I'm going to square the last term, which is 4 squared, which is plus 16. Let's do one more. How about 2y plus 3w squared. Okay? Again, I could write it out. Do 2y plus 3w times 2y plus 3w, do a FOIL, but let's do it the shortcut way. First thing, take 2y and square it. So 2y times 2y is 4y squared. And now I'm going to take 2 times the first term, which is 2y, so that's 2 times 2y is 4y, times 3w would be 12yw, and I didn't put them in alphabetical order because that's the order they're in here. And then 3y squared, 3w squared, and 3w times 3w is 9w squared. So 2y plus 3w squared is 4y squared plus 12yw plus 9w squared. The next little shortcut is very, very similar to the square of a sum, but we're going to do square of a difference. So we could have, for instance, a minus b squared. So when we do a minus b, again, I could write it a minus b times a minus b, and I could use FOIL, or I could use this little shortcut. And that's first square the first term, which is a squared. And then, in this case, it's going to be minus 2ab, because this is a negative b, and 2 times a times negative b would be negative 2ab. And then I square negative b, and negative b times negative b is positive b squared. So really the only thing that changes is this negative sign that's right there. Okay? So now let's use a real example. Let's do 2x minus 4 squared. Again, 2x minus 4 times 2x minus 4. Do a FOIL if you want to. But I'm going to do the shortcut. 2x squared is 4x squared, because 2x times 2x is 4x squared. 2 times 2x is 4x times negative 4 is negative 16x. And then I square negative 4, which equals positive 16. So the solution to 2x minus 4 squared is 4x squared minus 16x plus 16. Now let's try another one that throws in some more variables. How about 5b minus 6c squared? Square the first term. 5b times 5b is 25b squared. 2 times 5b is 10b times negative 6c would be negative 60bc. And then negative 6c times negative 6c would be positive 36c squared. And that would be my solution to 5b minus 6c squared. The last special product I want to look at is called the product of a sum and a difference. So it might look something like this: a plus b times the quantity of a minus b. It's a product, because I'm multiplying the two binomials, of a sum and a difference. Now I'm going to work this one out so I can show you something. So when we do FOIL, I have a times a, which is a squared. A times negative b is negative ab. B times a is positive ab. And b times negative b is negative b squared. Okay? I just used FOIL method, wrote it out. Now if you look in the middle, I'm combining like terms, but I have negative 1ab and positive 1ab, so those cancel out. And all I'm left with is a squared minus b squared. So the shortcut to all of this is when you have the product of a sum and a difference, and both of the first terms are exactly the same. They can't be any different whatsoever. They have to be exactly the same. And both of the b's are exactly the same. No difference whatsoever, exactly the same. One's plus, one's minus. Then I can just multiply the first terms and the last terms, and I don't have to do the OI. The OI is the OI in the middle of FOIL. There's no OI when I have the product of a sum and a difference. So let's look at a couple of real examples. How about 3x plus 4 times 3x minus 4? Again, exactly the same first terms and exactly the same last terms. One's plus, one's minus. I can do the shortcut. 3x times 3x is 9x squared. Positive 4 times negative 4 is negative 16. That's the final answer. What about this one? 2y minus 7 and 2y plus 7. Now the first thing you notice is that this one's minus and this one's plus. It doesn't matter. As long as one is plus and one is minus, 2y is exactly the same as 2y, 7 is exactly the same as 7. I can use my shortcut. 2y times 2y is 4y squared. Negative 7 times positive 7 is minus 49, and that is the final solution. One more. 4s plus 7t and 4s minus 7t. Again, exactly the same first term, exactly the same second term, plus and a minus. Shortcut, 4s times 4s is 16s squared. 7t times negative 7t is negative 49t squared. And that's my final answer. So here are your practice problems. The first one is 6x plus 4y squared. And the second one is 9m minus 8 squared. And the third one is 12r plus 11x times the quantity of 12r minus 11x. Now, do all three practice problems, take a picture, submit the practice problems in Edmodo, and then you're finished.